How paper is made, from tree to finished sheet. Have you ever wondered how a simple sheet of paper begins its journey? From towering trees in remote forests, to the notebook on your desk, paper is the result of one of the most fascinating, complex, and finely engineered industrial processes in the world.
Today, we're taking you inside the full story, from tree to pulp to paper.
This is the complete papermaking process, explained step by step.
Chapter 1. Raw Materials. The Beginning.
Our story begins with trees, nature's most important source of cellulose, the building block of paper. While cellulose can be harvested from cotton, hemp, grasses, and even agricultural waste, wood fiber remains the world's primary pulping material. Why? Because forests are renewable, abundant, and provide fibers with ideal characteristics. Cut to footage of forest. There are two major categories of papermaking trees. Softwood needleleaf trees, found in colder high-latitude regions. Long, strong fibers, produces paper with excellent strength and durability. Hardwood, broadleaf trees, found in tropical and subtropical climates. Short, fine fibers, great for paper smoothness and uniform appearance. Together, these fibers create the perfect balance for strong, uniform paper.
Chapter 2. Debarking and Chipping.
Once harvested, the logs arrive at the mill. The first step is debarking, because bark contains very little cellulose and would waste chemicals in the next stages. The clean logs are then cut into small chips. Think of them as tiny wooden tiles. This increases surface area, allowing chemicals to penetrate faster and more evenly. Large machines slice the logs in seconds, producing thousands of chips per minute.
Chapter 3. Cooking the Wood. The Kraft Process.
Now comes one of the most crucial steps. To free the cellulose fibers, mills use a chemical process called digesting, or more commonly, the Kraft Process, which produces more than 80% of the world's wood pulp.
Inside a giant pressure vessel called a digester, wood chips are cooked with a mixture of
sodium hydroxide, sodium sulfide. These chemicals break down lignin, the natural glue that holds wood fibers together. As lignin dissolves, it mixes with the spent chemicals, forming a dark brown liquid known as black liquor. Dramatic steam shots.
After several hours, the once solid wood has transformed into a loose mass of separated cellulose fibers floating in liquid.
Chapter 4. Washing and Screening.
Next, the pulp passes through powerful washing systems. Here, clean water removes the black liquor, leaving behind a pale yellow fibrous slurry. But not all fibers are perfect. Large screening machines remove uncooked wood pieces, dirt and sand, fiber bundles. Only clean, uniform fibers continue to the next stage.
Chapter 5. Bleaching for Brightness.
At this stage, the pulp still contains traces of lignin, giving it a yellow tint. To make white paper, mills use multi-stage bleaching. Each stage uses a different chemical to further break down lignin, safely and precisely. As remaining lignin disappears, the pulp slowly becomes bright, clean, and white.
Chapter 6. Preparing the paper stock.
Now the pulp is ready to become paper, but it must be carefully conditioned. Pulp dispersing. Dried pulp sheets or bales are mixed into water and broken into fibers. Refining. Mechanical refining beats the fibers, helping them bond better, boosting strength. density. Smoothness. Additives mixing. To give paper special properties, chemicals may be added. Wet strength agents. Fillers for brightness. Sizing agents for water resistance. Dilution. The pulp is diluted to a very thin mixture, often 99% water and 1% fiber. This watery mixture ensures a smooth, even paper sheet once it reaches the paper machine.
Chapter 7. The Paper Machine.
Now comes the most spectacular part of the process. Modern paper machines can be over 100 meters long, producing paper at speeds faster than a car on the highway.
1. The head box.
The headbox spreads the pulp mixture evenly across the forming wire. A perfectly even flow is essential for good formation. 2. The wire section. The slurry lands on a moving wire mesh. Water drains through it, leaving a wet mat of fibers, the first form of actual paper. 3. The press section. The sheet passes between massive rollers wrapped in absorbent felts. Pressure removes more water, strengthens the sheet, and smooths its surface. 4. The dryer section. Dozens of giant steam-heated cylinders evaporate the remaining moisture. By the end, the sheet contains only about 5% water. 5. Surface sizing. A water repellent or strength-enhancing coating is applied. This improves smoothness and creates better printing surfaces. 6. Calendering. The paper passes between heated steel rollers, enhancing gloss and uniformity. This gives paper its final finish.
Chapter 8. Coating, supercalendering, and cutting.
For premium papers, additional processing steps are applied. Coating. Special coatings polish the surface and increase brightness or softness.
Supercalendering.
Paper passes through a stack of alternating hard and soft rollers, sometimes up to 18 rolls. This produces extremely high gloss, magazine quality finishes.
Cutting.
Finally, enormous paper rolls are slit and cut to size. Printing sheets. Packaging rolls. Specialty applications.
Ending.
From the forest to the printing press. From rough logs to a smooth sheet. Papermaking is a remarkable combination of chemistry, physics, engineering, and precision.
If you enjoyed this deep dive into the world of pulp and paper, let us know in the comments below. And don't forget to like, subscribe, and share this video with someone curious about how everyday materials are made. Thanks for watching.